Okay, so the next way to solve a system is to use what's called substitution. Algebraically, I'm going to put a little asterisk on this one right here because it turns out that the substitution technique is probably the hands down the best one. It might not be the most easiest one, as you'll see in a moment here, but the thing that I like about this is that it works all the time. Recall there's also systems that are nonlinear. And so if we're solving a nonlinear system, you're definitely using substitution. So it works for linear systems or it works for nonlinear systems. It's a very strong situation. And so what I'm going to do is kind of write out a step-by-step procedure. And as I do that, I'll be going through the solution as we discuss this. Right? And so the first thing when I'm going to use a substitution, your first step is to basically pick a variable, right, to solve for and an equation. All right, so there's actually 4 choices you can make at this juncture for the work that's being shown. All right, I can solve for x in the first equation, I can solve for y in the first, I can solve for x in the second or y in the second. So I have to solve for one of them. All right, and I'm just going to choose an easy one because we've already done it. How about we solve for y? And we've already done that. Y is negative x plus 3. So there's step 1. Find what, solve for one of the variables in one of your equations. So step 2, what you're now going to do is sub into the other equation. Don't go back and substitute it in the equation you just solved. Substitute, I'll even change colors here. Substitute it in the other equation. So we're going to replace that y with what I said it's equal to right there. So we're going to make what is called a substitution, and hence the name substitution technique, because we're subbing. So this becomes 2x minus, and I'm going to go ahead and show my substitution in red because it's a good idea, right, to put what you're subbing your value in parentheses. That way you kind of get a gauge of everything that's happening around it. So everything is the same, right? 2x minus equals negative 6. What I'm subtracting though is changed because from the other equation I know what y is supposed to be equal to, negative x plus 3. So now what we can do, step 3, is we can solve for the remaining variable. Alright, so we can basically solve it now for the variable that's left over for what we did. Alright, and so in this case it's x, so we get 2x, distributing, we get plus x minus 3 equals negative 6. This is 3x minus 3 equals negative 6. Adding 3 to both sides, we get 3x equals negative 3. And dividing by 3, we get x equals negative 1, which is no surprise because we found that, right, doing our graphing technique. So this geometry, we basically have that. But we're only halfway done, right, because we're expecting an ordered pair. So our fourth one, right, is to take the value that we just found, right, and go back and find other value. Go back and sub, right, to find other value. So I'm going to come up here and replace that x with negative 1. Again, use parentheses. It's almost like I'm subbing again, right? I'm subbing a known value to find another value. And so we get 1 plus 3, and lo and behold, we get 4. So what's the ordered pair that solves that system? Well, graphically, we already know it's negative 1, 4. And then using my substitution technique, I have 1, 4. I guess step 5 is to basically check your work. Does it actually work? So that's how substitution is run. So you have 2 equations, you have 3 equations, you have multiple equations, you have a system. So your first order of business is to pick a variable, pick an equation, usually try to pick the easiest choice, and then solve for it. Once you've done that, don't change directions. Keep moving forward, right? You take that and you sub it into the other equation. That should now give you an equation with just one unknown, right? 1 by 1 system now, 1 equation, 1 unknown. You solve it using the things that we've learned how to do, right? And then step 4 is you go back and solve for the remaining variable by substituting the value that I have. And after that, you should have the solution. If you're not sure, you can check it by plugging it in and seeing that it actually solves both, right? So we have solved this system two ways now, visually by using a graph, and then algebraically by using a very famous substitution idea, again, that works all the time. There's actually a third way to do this, but I'll do that in the next video coming soon.